All right. Good morning from Chicago. This is Tim Stewart. I'm president at Visual Decisions, and I'm here today to talk about improving Kaizen with Industry 4.0. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since about 2002. It came from a lean manufacturing consulting firm, as well as a variety of other things in the background. And one of the key elements of implementing lean and performing continuous improvement is utilizing information to determine which Kaizen projects to run, and also then utilizing the information once you're in a Kaizen project to perform the root cause analysis and measure the impact of the event. So as we go through the presentation today, we'll take a look at how we've done that with our customers and how we continue to do that. So with that, let's go ahead and get started. So the agenda today is pretty straightforward. We'll take a quick look at what is Kaizen, what is Industry 4.0. If you're here, you probably know something about both. And then we'll go through some of the details of the different steps in a typical Kaizen project and how we can improve those utilizing the Industry 4.0 technologies. So what is Kaizen? At a high level, Kaizen is both a philosophy and an activity. As a philosophy, it is the belief in continuous incremental improvement that rather than trying to do the business process reengineering, as was popular back in the 80s, you'll do a lot more for the business if you just try to make the business a little bit better every single day. And as an activity, it is a structured event intended to improve a process, or a product. And it's really the structured activity to improve a process that we're going to talk about today. One quick note that I'll put out there is that manufacturing has really embraced technology over the past, well, it's always embraced technology and automation. And to a large extent, operational excellence teams have not. So when we look at all the innovations that have come to manufacturing over the past 10, 15, 20 years with robots and augmented reality and cobots and all kinds of different things that seemed futuristic just 5, 10 years ago, it's really amazing to see all of those things embedded into manufacturing processes across industries. But then when I walk shop floors, I still see whiteboards. I still see, things being drawn, up there manually. I still see, people printing out sheets that they manage in Excel and then posting those up there every day. And then, taking them down at the end of the day or erasing the whiteboard. And, the next day they, put something else up there. And then if you want to save it, you've got to take those Excel spreadsheets and you've got to continually put those into something else, or just you have a shared folder full of these Excel spreadsheets, and the whole process is very wasteful. And with the manufacturing process itself, even at Toyota, they have a philosophy of do it manually for a while, but then once you have, really honed the process, then you automate. And at this point, these whiteboards and, these SQDCIM boards and so forth are really due for some automation in the process. So what is Industry 4.0? Industry 4.0 encompasses a lot of different technologies. And over on the right side of the screen here, we have a visual from the World Economic Forum that is pretty comprehensive. At the center are some of the mainstream technologies and so forth, and then maturing and emerging technologies as you expand out from the center. And then it has different categories such as advanced materials and production philosophies and analytics and intelligence and so forth. And as you can see, there are a wide number of different technologies that are in play in Industry 4.0. Over on the left side, I've just listed out a few that are a little bit more relevant for our discussion today. And I'll be highlighting a few of them, such as big data. And by big data, I'm incorporating IoT and IIoT into that. Artificial intelligence and machine learning, augmented reality. These are things that are very, very applicable to looking at the Kaizen process and really how we can take steps in improving it. Just as a point of note, before I really get going here, if you have questions, please put them into the Q&A or the chat. Either way, I'll look at both as I go along. And if there are questions that I can answer in the flow of the presentation, I'll do that. Otherwise, I'll kind of queue them up for the end and take care of them then. So with that, what are the steps in a Kaizen event? And how can Industry 4.0 solutions really improve the process? So there are a lot of different structures to a Kaizen process. I've worked with a whole lot of different customers, and a lot of them have slightly different takes on what the steps are in the process. But at its core, it's pretty similar across different companies. And this is a very typical process, and it's one I had a visual for, so this is the one I'm using. And 6-step process: identify the problems, analyze the current process, create solutions, test them, measure and analyze the results, and then standardize the solution. And so, each one of those steps is very dependent on data. And it's very dependent on, for instance, in identifying the problems. How do you identify problems? Well, you need data for that. There are some things that you can see visually. If something blows up, then yeah, that's a problem. But ideally, you're making database decisions. You're going where the data takes you, and so forth. And certainly, as you want to analyze the process and create solutions from that analysis and so forth, you want to do that based on the information that you have. So let's walk through these steps individually and take a look at them. So step one, identifying problems. What is a problem in manufacturing? One way to look at that is the 7 wastes or 8 wastes. And if you know Tim Wood, transportation, inventory, motion, waiting, overproduction, overprocessing, and defects. And then typically a lot of companies will add an 8th waste of the underutilization of human potential. And all of these are things that you can identify with data that you can see in the data that you have within your organization. And if you don't have visibility to these things within the data, then that's where you might want to start augmenting the data collection that you have with some of these Industry 4.0 capabilities. And so some of these things are very typical within an ERP system, such as inventory. Anything that's transaction based that has dollar impact is going to be in your system of record. But some of these things, such as transportation, you may not actually see within there. And so those are things where if you put an RFID chip on your material lots, as you move those material lots around, you can actually trace that movement, and you can get a sense on how much transportation that you actually have within your organization. Something like overproduction. If you're tracking, production at a given station, it's a credit point in your ERP system, then maybe you have that information today. But it may be something where, for individual workstations and so forth, it's very easy to collect that information. You probably have a PLC or a controller if it's a automated process. If it's more of a manual process, it's still pretty easy to just have something that triggers that a piece has been produced and moved on to the next step. And so all of these things, you have the ability to collect information as you go along. And there are definite ways to do that with Industry 4.0 systems. And the next step with that, that kind of bleeds over into step 2, is not only do you want to collect information about, for instance, defects, but you also want to be able to collect information about what are the reasons for those defects. So it's not enough to know that my first pass yield went from 97% to 93%. That's not actionable. It means I need to pay attention to it, and it's good to know. But until I know why it went from 97 to 93, there's nothing I can really do about it. And so, old school, we went out there with a clipboard and stopwatch, and we started watching the line for downtime and things like that. We used tick sheets and so forth to collect information about why things were happening and how frequently they were happening. But there are better ways to do that now, and I'll get into those in a minute. Another very common way of looking at this is with KPIs, key performance indicators, and very often in manufacturing, especially in Lean Six Sigma houses, these are organized into categories for SQDCIME, safety, quality, delivery costs, inventory, manpower, and environmental. And as I mentioned earlier, for a lot of companies, especially around Lean Six Sigma, these are tracked in a very manual fashion very often and displayed on these boards, with people, either coloring in the sheets themselves or printing these off from Excel on a daily basis and posting them up, or a weekly basis and posting them up. And they're great because they're color coded. You can immediately see, am I green or am I red, or yellow for some companies. And that's great. It's visual. It's very easy to see where the problems are. But again, can be done in a much more automated fashion and a lot less waste in the process. I mean, this person here that's doing this on a manual basis, I would argue that we're seeing a living example there of the 8th waste of the underutilization of human potential. So how have we addressed this in other customers? This is an example of where we built a KPI dashboard that the COO used on his weekly cadence calls with his direct reports. But then we used that same type of interface all the way down to the shop floor. So the key here is that we were collecting the information for all of these metrics from the shop floor itself around all of the different KPIs. There are 43 here, I think it was, around SQDCIM. And we bottled that information at the source, so to speak, and then rolled that up and aggregated it across those different systems, and then presented it in a way where on a 20-minute or 30-minute cadence call each week, the COO could just focus on those red boxes, and he could talk to each plant manager and ask, why did you miss your OSHA rate in this time period? What were the drivers behind that? What was the explanation? And then what are you doing to address that? And then he'd move on to the next one and the next one and so forth on down. And the plant manager, when they were talking with their team, they would be able to look at this, and instead of seeing the different plants, they would be able to see their different cells or their different lines and so forth, and be able to have that same conversation. The line managers could look at the different resources and so on. And so that drill down was there in the application, and was very easy to configure and maintain that information as we went along. And as we look at information from the shop floor, I mentioned that we bottled things at the source. And within your environment, I guarantee that data is generated at every step of the process. Whether you're capturing that or not, and whether you're persisting that information or not, information is being generated at every single step. And it's just a matter of being able to capture that, persist it, and then being able to access that in an easy way so that you can see where those problems are and identify where you have opportunities for improvement. Once you have visibility to all of these issues, then the next step here is kind of choosing which one should we work on first. And just kind of a quick note on this, it's key to be able to put a dollar figure to those different problems and understand that within the business context of how big of a problem is this. You don't want the squeaky wheel to get the grease. You actually want to make decisions based on, is this a really high value or is it low value? Is it fast to implement? Is it slow to implement? How much of an investment in time, capital, and resources do I have to make in order to make this improvement? Are there things that are interdependent that have links between them so that if I improve one thing, I can actually get results in a number of different areas? How confident am I that my people are ready for this change and so forth? And then do these things line up with the overall priorities for the business? And so being able to put things on these different axes and being able to look at those is also very important for picking which ones to attack first. So once we know all the problems in the business and once we understand how big they are and which ones I want to work on first, the next step is actually running the Kaizen process on that problem. And so the first step or second step is to analyze the process. And there are a lot of different methods for analyzing the root causes for problems and understanding the process itself. And depending on the nature of the problem, different methods are most appropriate. And depending on the people that are involved and their skill sets, you may choose different methods for doing that. Next week, in the same webinar series, we're actually going to be taking a really deep dive into the root cause analysis and how we can modernize that root cause analysis using the same tools that we're using for Kaizen. So we'll do a deeper dive into that aspect of things next week. But at a high level, what we want to be able to do is to be able to access data. So just as an example here, looking at a fishbone or an Ishikawa diagram and so forth, you're looking at a problem and you're trying to decide what are the causes that impact that problem, whether it's man, machine, material, method, management, environment, etc. And not only what does impact it, but how much does it impact it? And for those, you can very easily tie in if you have, for instance, an OEE system that collects the amount of downtime, as well as what were the individual causes for the downtime. Now, this fishbone diagram can become a Pareto of what are those different factors that are driving that downtime for that machine. And so if we're collecting that information 24/7, if it's always on from a data collection point of view, when we start that Kaizen event, we'll have that information. And really, this is exactly what drove me to found Visual Decisions years ago. As I was doing lean consulting, I got so tired of looking at these processes and saying, okay, I've got to stand out there, I've got to collect data, or all I have is tick sheets, and I know that the tick sheets aren't representative. The short stops aren't getting enough ticks, and the information doesn't contain how long was that downtime, etc. And so being able to collect all this information in detail all the time was just such a huge benefit that we really got into the business of looking at how do we combine that real-time data collection with those lean practices to really bring the best of both of those to companies for the continuous improvement project. One more thing I'll say about standing out there with a clipboard and a stopwatch. The Hawthorne effect means that you're going to collect biased data. When somebody knows that they're being watched, they behave differently. And if you're driving out on the road and you see a policeman on the side of the road, you slow down. And it's the same thing, at these stations. The operator just behaves differently when they know that somebody is standing there collecting data. And it may not be that they're necessarily trying harder, but they're just doing things differently if they know they're being watched. And so to really get an unbiased view of the process, you have to collect data all the time, every day. And that's the only way that you're really going to collect the unbiased data. So as an example of this, working with a bread manufacturer, baker, we looked across a number of different plants and collected data directly from the shop floor. This was a homegrown system that they were using at the bottom level, at the machine level, and they were collecting that information and they were putting it into a database. And we helped them build both that data collection as well as the interface on top of that to really analyze that information. And so in addition to some of the high level aggregate information, we wanted to be able to drill down into the process to be able to analyze, ask why several times. And so essentially, if I want to know, why is this machine going down? Well, I've got at the top level this area, and I can say, well, equipment loss is my biggest contributor to, that machine being unavailable. And if I drilled into the the equipment loss, what I would see is that the oven is the biggest category within that area. And I could continue to go down. And what I see then is that I've got most days very little loss due to the oven, but then I have these really big spikes. And because of that pattern, what we were able to determine is that we needed to collect information about, the details of what was happening when those occurrences occurred. So we had the operators put in notes for each one of those different occurrences. And what we found was that the oven was failing because the pins that held the conveyor as they were going through the oven were fatiguing, and pins would break and the oven shelf would flip. And of course, then we had to stop the conveyor. We had to cool down the oven. Then we could go in there. We could pull out the burnt bread, and then fix the conveyor, and then reheat the oven, and then actually restart the process. So every time that this happened, it was a tremendous amount of time loss. And so these big spikes were occurring. Well, we were able to identify that cause, and then we could put a PM program in place to both just on an off shift or on an off day, have somebody inspect those pins, see where they were getting fatigue, replace them on a more regular basis, and we eliminated this entire source of downtime and raised the OEE of the equipment by a significant amount just through this one change. And the change itself was very simple, and you could say that, well, we should have been doing that in the first place. But until we had the data and until we saw how much time we were losing, it wasn't a priority. And so, it's having that data, understanding where those problems are, step one, and then understanding the cause for that, step two, that really helps us, identify what are the things that we need to do and why do we need to do them. So that brings us to step three. In the case of the bread manufacturer, this step three was pretty obvious. We just, implemented the PM program to change the pins more frequently and so forth. But sometimes it's more complex. And so step three is creating solutions to the problems that you identify. And usually the way that you want to go about this is to look at a number of different alternatives. And so in step three, you want to brainstorm, you want to utilize some cross-functional teams. You want to incorporate vendors, partners, customers, where required or where beneficial. Support for input from remote locations used to not be a big deal. Fly them out if it made sense. But now having some of those augmented reality capabilities and so forth to be able to get visibility into the process for those external experts can be extremely beneficial. Being able to track what has been done before and utilize those best practices is something that's very underrated. So being able to see, this machine has had this failure before. What did we do then? And if it's something where, as an example, one of the fixes that I had with a customer when the conveyor jammed on an overhead bottle feed was to grab a broomstick and poke that until the bottle started feeding again. Well, that's great. It works. It's not exactly a Kaizen process, but it cleared the jam. But we actually put in a Kaizen process to figure out why it was jamming, and then fix the feed so that it didn't jam anymore, and implement more of a permanent change. And then you want to be able to generalize and extend your solutions to other processes as well. And so as we look at this, one of the big impacts for Industry 4.0 is broadening that solution space. So for the number of different solutions that you have for some of these problems, if all you have is a hammer, every problem looks like a nail. But for some of these different technologies, they can provide solutions that just simply weren't available to you in the past. And so if one of your problems is that when these machines go down, it's taking too long for our maintenance department to respond. Well, you have opportunities with some of the augmented reality technologies to have a centralized maintenance team that can help the operators. They can just put their phone on the machine and so forth and show what's going on with it. And a maintenance person might be able to diagnose and give instructions to the operator to fix simple issues without having to wait for the maintenance person to get to the machine itself. And so you can take care of some percentage of the problems without having to have that time built in there. And so there are a lot more solutions that are possible with some of these technologies than what you had in the past. So broadening that solution space is quite valuable from an Industry 4.0 perspective. Just continuing on that theme with IIoT applications, there's a huge number of different things that you can do with the industrial Internet of Things. And these can provide either solutions for some of those problems, or provide the information to solve some of those problems. And so again, a lot that you can do that hasn't been possible in the past because of this advancement in technology. Step 4 is testing the solutions once you have them in place. And what I like to do is, I had a question that came in. What did the different colors and sizes of circles stand for in the previous slide? Oh, that one. The different colors were the interdependencies. So the blue ones kind of fit together. So if I made a change in the blue ones, it made sense to do both of those. The green ones in the center section here kind of tied together, the yellow ones tied together. And then the yellow, or the size of the dot was, kind of my level of confidence in how I would be able to solve that problem. So, this yellow one here was a great one to work on because it was high value, it was fast, and I had very high confidence in the project being a success, that my people were ready for it and would embrace it and so forth. Sorry, I didn't notice that until now. So as we go to test the solutions, one of the things to look at is, starting small and Once you understand, how well that actually works, then be ready to scale something quickly. If you are implementing technology to address some of these things, you want to make sure that you adapt the process and provide adequate training to people for that process change. Simulation provides another key capability here from an Industry 4.0 perspective. So, as I'm looking at a process change, if it's something that requires capital investment, if I can simulate that in advance of making that investment and having a good understanding of if I fix this part of the problem, will it address everything overall, is very beneficial. And if it's something where you're working with, for instance, an IIoT platform to be part of the solution, using agile approaches to implement and build things quickly and then iterate is, first of all, it fits in with the entire Kaizen mindset and is actually the agile design approach was based on lean manufacturing. But having that approach of putting that minimal viable product in place and then incrementally improving it to test out the solution is something that has a lot of benefit as well. So as you're looking at software and platform types of solutions, that approach has a lot of value. So step 5, measure and analyze the results. I've been hitting data very hard as I've been going through here, and the benefits of data. And obviously this is one place where I'm going to do that again. So if you're looking at measuring and analyzing the results, obviously the more you can do to have something that collects data 24/7 in that unbiased fashion and being able to easily analyze the results is absolutely critical to this. For a variety of reasons, our preference for data collection in general is to use an IIoT platform due to the inherent flexibility. If you already have something like an MES system in place, that's fantastic. And you can utilize that MES system. But for some of the edge cases and so forth, it can be difficult to adapt an MES. So you can augment that with an IIoT platform or something along those lines to handle some of those edge cases. But really, the IIoT platform allows you the flexibility to not only have something that does that data collection, but allows those agile philosophies to come into play where you can very quickly put a solution in place and then just iterate on that to really improve that over time and make it a better and better fit, as opposed to a more monolithic solution. And so, we have experience with a lot of different platforms and a lot of different solutions. So, these are things that we can help with our customers in terms of how to best use the solutions that they already have without having to buy something new, or what might be a good augmentation for the solutions that they have in place already in order to drive better measurement, analysis, and so forth. Excuse me for 1 second. Apologize for that. I have a cold, and so just needed to take a break. The next step, or the final step, is to standardize the solution. And I cannot emphasize enough the key role of standard work here. When we think about standard work in manufacturing, the first thing that pops into mind is getting all of the operators to work with the equipment in the same way every time. And absolutely, that is part of the solution. But we also have to think about the leader standard work, and having the team leaders and the supervisors and value stream managers and executives all be a part of this solution, and looking at the data that we're collecting from the shop floor, having a process like that COO example that I gave earlier with his weekly cadence call where he was looking at that data. That is really what is going to help standardize a lot of these different solutions that you put in place, is to really put that into the standard work that happens on the shop floor on a shift by shift, day by day, week by week basis. I'll also talk briefly here about when we talk about standardizing the solution, we could also say systemize the solution. And so one of the benefits of putting a software solution in place is that it actually really helps to standardize that approach across different shifts, across different operators, across different processes within your organization. And so being able to utilize a system to really make that standard across the organization can be very beneficial. Now, the downside of the danger of that is that you don't want to create monuments in the business that then become part of the problem of being flexible in the future. And so, as you systemize that solution, you have to keep in mind that at some point in the future, you may want to adapt that and make changes going forward. And so, kind of a double-edged sword with utilizing software in these places, but there are ways to implement those things that maximize the benefit and minimize the negative. And where you are utilizing Industry 4.0 technology, it's definitely not enough on its own. I use the example of a Fitbit all the time, where I've been wearing a Fitbit for 7 years now and really haven't lost any weight. And it's not that the Fitbit itself is broken. The Fitbit works fine. It collects, tracks all my steps, and presents all kinds of nice, pretty charts and graphs and everything else. But I haven't changed my behaviors. And so with any technology implementation that you're doing, you have to keep that in mind. You have to change the behaviors of people. Fundamentally, they have to do something different tomorrow than they do today. Otherwise, you're not really making a change. You're just spending money. And so as you're looking at standardizing that solution, keep that in mind, that you have to create that culture of data-driven improvement, and you have to adapt processes to take advantage of any new capabilities that you put in place. So some closing thoughts. I'll say it again, data is absolutely critical to identifying the opportunity improvements, or the improvement opportunities rather, analyzing causal factors, generating solutions, and more. Caution has to be put in place though, or caution has to be used to avoid technology monuments. You don't want to, put something in stone that you're not going to be able to change later on, because situations will change and you're going to want that flexibility going forward. So you should choose solutions that are easily adapted and improved. There's a strong overlap with agile concepts and incremental improvements and so forth. And our recommendation is to utilize solution platforms such as IIoT and AR. If you are utilizing an MES, look at an MES that has those capabilities of, for instance, being model driven and things like that, that allow you that flexibility going forward. And then continually improve the process and look at the process and the technology together. So with that, I'll open it up for questions. If there's no more questions, then thank you. Again, you can reach me at tim@visualdecisions.com. My phone number is 630-957-8096. If you go to my website at visualdecisions.com, you'll be able to see all of the different videos there. You can click on links to get copies of the presentations and so forth. This one will be up at some point, probably tomorrow morning. And again, I encourage you to register for next week's webinar, where we do that deeper dive into the root cause analysis and how to utilize these same technologies to support that process. Thank you very much.